Welcome back everybody to this revision video on bit manipulation. First, let's start with a logical shift. This logical shift will move the bits left or right, and the bits that are beyond the given limit are deleted and replaced with zeros on the other end. So we can see here that when it is a logical shift left of 4, these 4 bits will move 4 spaces this way and end up here. And then these will all be deleted and replaced with zeros on the other end. An arithmetic shift will keep this first bit the same throughout the shift, as this is likely a signed bit that can be used in 2's complement or sign and magnitude, for example. Then the rest will follow the same pattern as a logical shift. So here, these 4 bits will move 3 to the right and be replaced with zeros at the end there. A cyclical shift is almost like a circle. So, for example, here, this 1 and 0 at the end will be shifted 2 to the right. Now, normally, in a logic shift, these would then be deleted and replaced with zeros. But in a cyclical shift, they will actually end up at the beginning here. And the rest will, again, just move 2 to the right. So let's say we have a situation here where we've got a factory with windows 1, 2, 3, 4, 5, 6, 7, and 8. If 1 is stored, then it is open, and if 0 is stored, then it is closed. In this first example here, we have the windows in a random configuration, and we would like to close all of the windows. Then we will simply use an AND operator with 8 zeros, as this will result in 8 zeros at the end, meaning all the windows are closed. Similarly, if we have a random configuration of windows here, and we want them all to be open, we will use an OR operator with 8 zeros so that it will all end up with 1s. In this situation here, we want to keep all the windows the same except for the first window, which we want to be open. So this could be used, for example, if a plant needs more water than other plants, it could be done this way. So we will use an OR operator with 7 zeros and a 1. And this 1 will cause the first window to open, and these will stay the same. Let's try some exam questions. The accumulator currently contains the binary number 00110101, and it wants us to perform a logical left shift of 2. So we know it will shift left by 2 spaces, so we know that these first 2 will be deleted. And then, starting from the left, we can copy the rest of this number here. 1, 1, 0, 1, 0, 1. And then we will just place 2 zeros here to replace the ones that were lost. The accumulator currently contains the binary number 00110101. Identify the mathematical operation that the following instruction will perform on the contents of the accumulator. So when you do a shift, a logical shift, to the left or to the right, you're either multiplying by 2, which is a left shift, or dividing by 2, which is a right shift. So here, we're dividing by 2. We're dividing by 2 3 times, which is the same as dividing by 8. As we can see, this is the mark scheme for these questions. Let's try a different style of question. The current contents of main memory are shown, and it gives addresses and data stored in the addresses. Each row of the following table shows the current contents of ACC in binary and the instruction that will be performed on those contents. Complete the table by writing the new contents of the ACC after the execution of each instruction. So let's start here. We've got this current contents of the ACC, and we're doing OR 101. Now 101 is not a number, it's the address that we need to go to get the number. So we'll go to 101 here, and we'll find that it's 11110000. So let's just write that in here, 11110000. And now we just OR the two. And since the contents of the ACC is all ones, the new contents of the ACC will also be all ones. Moving on. So the current contents of the ACC is 8 zeros. We want to exclusively OR this with the denary number 15. That's what this hashtag 15 means. So here we need to convert 15 to binary, which is 00001111. And now we need to exclusively OR this with the contents of the ACC, and we'll get 00001111. And here they wanted to perform a logical shift to the right on this number here. And that will just be 00101010. Now the current contents of the ACC is 01010101, and we want to AND this with the data from the address 104, which in our case is 000000. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Now we want to AND this, and to have an output of 1 in an AND, you need 2 ones. And since these are all zeros, this will be 00000000. So you can see there's the mark scheme. Now we can move on to this hardest question I could find. So this is the contents of the address 300. An assembly language program needs to test if bit number 2 in memory address 300 is a 1. Complete the assembly language instruction to perform this test. So, we know from our Unit 1 knowledge that the denary number 4 is in 8-bit binary is 00000100. And this is handy because this is the same as the bit number 2 in address 300. So if we AND them together, then we will get the rest as zeros, and if 2 is 1, then we'll get a 1, but if it's not, then we'll also get a 0. Question part 3. An assembly language program needs to set bit numbers 4, 5, 6, and 7 to 0, but keep bits 0 to 3 with their existing values. So what kind of operation will we need to perform here? Again, it will be an AND. But what do we need to AND it with? We need the first 4 to turn to 0. So we're just going to put 0, 0, 0, 0 as anything and 0 is going to be 0. And now we need these to keep the same. If it's 0, we want it to be 0. Then we can AND it with a 1 to get 0. But if these two are 1, then we want to keep it a 1, and we're ANDing, we would need a 1. So we have a 1, 1, then it's the same as the bit number 3, 1. And this in denary is 15. So we're going to do AND, hashtag, signaling it's a denary number, and then the number 15. Thank you for watching.